afternoon, sir. So, the topic I choose for today is all about intermolecular forces and intramolecular forces. An intramolecular forces is any constraint that ties together and making up an atom or compound, not to be confused with intermolecular strength, which are the strengths shown between atoms. The unobtrusive distinction within the title comes from Latin roots and English with connects meaning between or among, intra meaning interior. Chemical bonds are considered to be intramolecular strength. For illustration, three strengths are frequently more grounded than intermolecular strength, which are not shown between molecules or atoms that not are fortified. Intermolecular atoms are the powers which intervene interactions between atoms, counting strengths of fascinations or shocks which act between atoms and other sorts of neighboring particles. Intermolecular atoms are powerless relative to intramolecular forces which hold an atom together. For case, the covalent bond, including sharing electronic set between particles, is much more grounded than strength shown between neighboring particles. Both sets of strengths are fundamental parts of drive areas habitually utilized in atomic mechanics. Figure of intramolecular polar covalent holding inside H2O particles and hydrogen holding between H and O. London scattering powers, finito category, van der Waals strengths. These are the weakest of the intermolecular powers and exist between all sorts of atoms, whether ionic or covalent, polar and nonpolar. Intermolecular forces are weaker than intramolecular strengths. Illustration of intermolecular strengths incorporate the London scattering drive, dipole-dipole interaction in dipole interaction, and van der Waals powers. Covalent, ionic, metallic. Ionic bonds, hydrogen bonds, van der Waals dipole-dipole interaction, van der Waals dispersion forces. Intramolecular forces are those within molecule that keep the molecule together. For example, the bonds between the atoms. Intermolecular forces are the attraction between molecules, which determine many of the physical properties of substance. As I said here, intermolecular forces are important since they are the driving cause of difference in physical properties between comparable molecules, softening and boiling points when molecules go from solid to liquid or liquid to gas. Intermolecular forces are weaker than intramolecular forces of attraction but are important because they determine the physical properties of molecules like their boiling point, melting point, density, and enthalpies of fusion and evaporation. Intramolecular forces are the forces that holds atoms together with the molecules. Intermolecular forces are the forces exist between molecules.